All right, hello. In this video, I'm going to be going in depth, reviewing how to predict reaction products of single or double replacement reactions. So the lesson that we started last week on Thursday and Friday, predicting reaction products, this assignment here that we started, I know, based on my previous experience teaching this course, that many students have trouble with this particular concept here. We're taking a lot of knowledge, a lot of previous knowledge, a lot of previous skills, and sort of putting it all together here. And so I think it's just useful to spend 2 days on this and to put together this review video for those of you that are still struggling with this. Hopefully, watching this video and seeing the examples here will help. Okay, so what I'm going to do, we did the first 3 of these in class. I have a recording of the Zoom classes from last week, so if you would like that, please let me know. Send me an email, and I will send you the link to the recording. What I'm going to do here is I'm just going to go through number 4, and I'm going to go through it in excruciating detail. Okay, so I'm going to go through every single step, showing you where I'm getting every piece of information, and then the hope would be that you can sort of replicate my steps, what I do here to help you solve the other problems if you have been unable to do so. Okay, so the directions here, we're going to be predicting the products of these reactions. These are all single or double replacement reactions, by the way. We're going to be predicting the products based on the given reactants. Okay, so what we have here are a bunch of chemical equations. These are incomplete. We only have the reactant side of the chemical equations. And so what we're going to need to do is predict the products, writing both the names and the formulas of those products here on the right side of the equation. Okay, and actually I forgot to do something. I need to make this a Zoom call here really quickly, not because you need to be in Zoom right now or anything like that, but making this a Zoom call actually enables me to, how do I do this here? Here we go. Making this a Zoom call actually enables me to do the share screen. And now I can actually write on the screen here. Okay, perfect. Okay, so once again, these right here are the reactants of the chemical reaction, and we're supposed to be predicting the products based on these reactants. Okay, so the first thing we have to understand is, what does a single or double replacement reaction look like? Okay, well, they're called replacement reactions because there is a switcheroo that happens. Okay, number 4 is going to be a double replacement reaction because I have 2 compounds as my reactants. Number 3 would be a single replacement reaction because I have a single element plus a compound. That's the difference between a single and double replacement reaction. Double replacement reactions are going to have 2 compounds. Single replacement is going to be a single element plus a compound. Okay, so this is a double replacement reaction. The generic form of double replacement reactions, you can find this information in the 4.1 notes, by the way, types of reactions. The general form of a double replacement reaction is as follows. You're going to have 2 compounds, like I said, AX plus BY. These letters here represent the cation and the anion of these 2 different compounds. Okay, and what happens is the positive anions, or sorry, the positive cations here are going to swap places. Or you can look at it 2 different ways, okay? Or you could look at it as if the negative ones are swapping place with each other, okay? Or, not both, okay? Or, either way you look at it, you're going to end up with the same products, okay? Here's what I mean. If A swaps with B, swaps positions, swaps compounds, then A is going to be with Y, and B is going to be with X. Okay, these are the 2 new compounds that I have produced. All right. If X swaps with Y, then X is going to be with B, and Y is going to be with A. Okay, so it doesn't really matter which one of these you do, if you swap A for B or X for Y, as long as you're swapping the positive for the positive or the negative for the negative, you are going to end up with the correct products. Okay, just don't do both, or else you're going to end up with the exact same thing that you started with, and that's not correct. Those are not the products, those would be the reactants again, right? So what we need to do then is we need to look at number 4, and we need to identify what are the positive and negative components here, okay? All we have are the names of these, all right? So this is the part, or this is one of the parts where I know a lot of people are going to get stuck, all right? So I'm going to try to leave this on the screen. It might get a little bit messy here, but I'm going to show you where we can find the charges of these different things. Are they positive or are they negative? That's a big question, okay? So something like sodium, that is an element, okay? Sodium is on the periodic table. Here is sodium. And something that we talked about last semester was the ionic charges on different elements on the periodic table. We labeled the following numbers on our periodic table. These different columns here that I am labeling these numbers on, and like I said, I know this is kind of messy. These different numbers here tell you the ionic charge of any given element based on its position in the periodic table. Sodium in this first column has 1 valence electron. It's going to lose that electron, okay, and it's going to end up with a positive 1 charge. You don't really need to know the details of that for this particular skill, okay, but there you go. All right, sodium is going to end up with a positive charge, okay. So if I go back to my work over here, let me clean this up a little bit. Sodium, I know based on what I just saw there, sodium is going to have a positive 1 charge. Okay. Well, what about sulfate? What about that? Well, you might think that sulfate is referring to the element sulfur, okay, which is underneath the AY here, but that is not true. Sulfate is a polyatomic ion. Okay, if it was referring to sulfur, it would be called sulfide. Okay, the suffix IDE usually refers to elements on the periodic table. Suffixes like ate or ite are always referring to polyatomic ions. So this list of polyatomic ions in the 4.0 notes, the Ionic Compounds Review, has the formulas for these different polyatomic ions. As you can see here, the formula is SO4 with a -2 charge. Okay, so we can head back over to our sheet here, and I'm actually going to write this down, SO4 with a -2 charge. Just to be a little bit complete here, sodium has the formula of Na, right? Na for sodium. All right, so that's my positively charged cation and my negatively charged anion for the first compound. I need to do the same thing for the second compound. I'm going to go through this a little bit quicker so as to keep the video at a manageable length. Okay, strontium, element symbol Sr. If you look on the periodic table, it's in the column with the number +2. Okay, strontium is going to have a positive charge of +2. Chloride, okay, once again, like I said before, ide usually means that we're talking about just the element, not a polyatomic ion. This is just referring to chlorine, which, once again, those charges on the periodic table, chlorine is in the column with -1 charges, okay? So this is the big first important step that we have to do in all of these problems. Identify the cations and anions. Which one's positive, which one's negative? What's their formula? What's their charge, right? That's what we need to do first, because that enables us to then figure out which one we are supposed to swap for the other. I can do the positive for the positive, or I can do the negative for the negative. I can do one of these options here, and I'm going to end up with the correct products either way. Okay? So perhaps I swap the positives with each other. Okay? I'm going to end up with sodium chloride and strontium sulfate. You might be thinking, why not chloride sodium and sulfate strontium? Well, that's because the positive anion, or sorry, the positive ion, the cation, is always listed first before the negative anion. So it's always positive, negative, positive, negative. It's never negative, positive, or negative, positive. Okay. So these are the names, right? That's one objective here. That's one of the things that we're asked for. These are the names for the products. The next thing we need to do is figure out their formulas. This is something that we should be good at. We did this in the fall. We did this at the very beginning of this semester because I knew it was going to be important, so I decided to practice it again, and we're doing it again, right? It's a skill that we have to know we have to be good at this because we're going to be doing it so often. So what we have to do is determine the formulas of these different compounds here. We have all the components over here, their charges. So all I have to do is figure out what would the formula of the compound be. The only rule, not the only rule, the most important rule when it comes to ionic compound formulas is that you have to understand that every ionic compound has to have an overall charge of 0. Every ionic compound must be electrically neutral. So the formula is going to reflect that, okay? So sodium has a positive 1 charge, chloride has a negative 1 charge. If I have 1 sodium and 1 chloride ion, okay, so 1 sodium ion, 1 chloride ion, those together are going to have an overall charge of 0. Positive 1, negative 1, it cancels out. So my formula for this is pretty simple, NaCl. I don't have any numbers here. I don't have Na2 or Cl2. I don't need any numbers. I just need one of each. So NaCl, that's my formula. Strontium sulfate. Strontium has a positive 2 charge. Sulfate has a negative 2 charge. Once again, I am looking at a +2, -2. These are going to cancel each other out. So I don't need multiple strontiums. I don't need multiple sulfates. I just need one of each. Strontium sulfate. Sr, SO4. 1 strontium, 1 sulfate. Okay? There you go. That's it. Those are my names. Those are my formulas. Okay? So just to do a little bit of a recap here, figure out if you have a single or double replacement reaction. Think about what that looks like. You're always going to be swapping plus for plus or minus for minus. Okay? Determine the charges on your different components. Okay? Sodium was +1, sulfate was -2, strontium was +2, chlorine was -1. Those charges come from either the location of that element on the periodic table or the charge of that polyatomic ion based on this table here. Okay, so this particular this set of slides here, this slide here, the polyatomic ions, and then your labeled copy of the periodic table, those two things are very useful when working on an assignment like this. So you determine the charges there, then you do your switcheroo. That's how we ended up with sodium chloride and strontium sulfate as our two products. And then you make the formulas, or you build the formulas of those compounds according to that rule of, the overall charge has to be 0. Okay, so that is the full process. I know that seems very involved, but for those of you that have been, paying good attention and keeping up with the content, you're probably already feeling pretty good about this. But for those of you who are still struggling a bit, I'm going to direct you to this video so that you can watch this and see everything explained in detail. If you're still having some trouble after watching this video, then we probably need to schedule a time to meet individually, perhaps on Wednesday this week, on C-Day. That might be a good time for us to do that. All right, I'm going to leave it at that. Thanks for watching. I will see you in class.